transportation, agriculture, industry. What do these things have in common? They all depend upon the fuels and lubricants that come from petroleum, the substance we call oil. What is oil? Where does it come from? How do we find it? Why is it so important? These are some of the questions we want to answer in this film. The story of the oil industry in this country starts in Titusville, Pennsylvania in 1859. At that time, Edwin L. Drake drilled the first successful oil well. Soon, oil was discovered in several other states. Later, with the coming of the automobile, the oil industry had to grow rapidly to meet the increasing demand for gasoline and lubricants. 2 world wars also forced America's oil industry to expand. Large quantities of petroleum were needed to supply fuel and lubricants for airplanes, tanks, and ships. Since World War II, the demand for petroleum has steadily increased, and today, oil and natural gas provide about 78% of our energy needs. As a result, the oil industry has become one of America's largest and most important industries. Petroleum deposits have been discovered in many parts of the world and in all climates. In the temperate areas of North America, in the tropical jungles of South America and Indonesia, in the frozen Arctic regions of Alaska, on the offshore shelves of the world's oceans, and in the parched deserts of the Middle East and North Africa. This area has the richest deposits yet discovered. In fact, the Middle East and North Africa have almost 65% of the world's proved oil reserves. Proved reserves are deposits that have been located and which can be removed economically using methods and equipment now available. The Middle East and North Africa combined have proved reserves of over 400 billion barrels. A barrel is 42 gallons. Indonesia has proved reserves of 10 billion barrels. In the communist world, Russia has proved reserves of about 80 billion barrels, and communist China 20 billion barrels. The Western Hemisphere has proven reserves totaling almost 76 billion barrels. Of this amount, South America has 27 billion barrels, Canada over 9 billion, and the United States about 37 billion barrels. The primary oil-producing states today are Texas, Louisiana, California, Oklahoma, Wyoming, and New Mexico. Smaller amounts of oil are produced in Kansas, Mississippi, Illinois, North Dakota, Pennsylvania, and West Virginia. In the 1960s, oil was discovered on the north slope of Alaska. Eventually, this field will contribute about 2 million barrels of oil per day to America's supply. Overall, the world's proved oil reserves total more than 627 billion barrels. If we continue to produce and use oil at the present rate, these proven reserves will last about another 40 years. But petroleum scientists know that perhaps 2 to 3 times this amount will eventually be found and recovered. Scientists believe the oil we use today was formed from marine plants and animals that died and settled to the bottom of ancient seas millions of years ago. These elements were covered with layers of mud and silt. As the Earth's inner heat and pressure changed these layers into porous rock, the plant and animal remains were changed into oil and natural gas. How this happened is still a mystery. Some scientists believe that bacteria or radioactivity may have been involved. The oil collected in pockets or traps formed as the Earth's crust shifted. The anticline trap is an upward fold in the Earth's crust that forms an arch or dome. A fault is a trap formed by a break in the layers of rock. A salt dome is a trap formed by an upward thrust of a layer of salt. Today, the search for oil and natural gas is based on our knowledge of how these traps were formed in the Earth's crust. Oil exploration starts with a geologist, a scientist who studies rocks and the effects of natural forces upon them. First, he studies maps and aerial photographs that show surface rock formations. These materials help the geologist select an area for oil exploration. After securing permission from the landowner to explore on his property, the geologist examines any exposed rock strata. He looks for clues that could indicate the existence of underground oil traps. The search for oil also requires the work of another scientist, the geophysicist. He uses sensitive instruments that help locate underground structures that may contain oil. The gravity meter measures differences in the pull of gravity caused by underground rock formations. Another instrument called a magnetometer helps the geophysicist chart differences in the Earth's magnetic field. The seismograph, which was first used to record earthquakes, is also used in the search for oil. After a charge of dynamite is set off, the seismograph records the echoes from rock formations below the surface. This information helps the geophysicist locate traps where oil may be present. But the only way to find out if an oil deposit actually exists is to drill a well. The first step in drilling is to build a derrick or drilling rig. Sometimes portable derricks are used. Most drilling is done by the rotary method. A bit is attached to a string of drill pipe, which is held by a rotary turntable on the derrick floor. As the engine rotates the turntable, the bit bores into the earth. Liquid mud is pumped down the drill pipe and back to the surface. This flushes away cuttings, cools the bit, and controls the pressure of any gas, oil, or water the drill bit may encounter. As the bit digs deeper into the earth, more drill pipe is attached. Whenever the bit becomes dull, all the drill pipe, sometimes thousands of feet, must be pulled from the well so the bit can be changed. As the hole deepens, the well is lined with steel pipe called casing to prevent cave-ins. Drilling an oil well is an expensive and risky business because there's no guarantee oil will be found. In fact, 8 out of 9 wells drilled in a new area never find oil. If oil is found, the drilling rig is removed and a system of valves is installed to cap the well and control the flow of oil to nearby storage tanks. Usually, the natural underground pressure is enough to cause the oil to flow. When the underground pressure drops, pumps are used to bring the oil to the surface. This process, called primary production, is able to remove only a small part of the oil. Sometimes, as much as 80 or 90% of the oil remains underground, trapped in cracks and tiny pores in the rocks. To remove more of this oil, engineers have developed a water flooding process. Injection wells are drilled into the rock formations. Water is forced or injected down these wells. The movement of this water pushes the oil out of the cracks and pores of the rocks. So a production well can be used to pump the oil to the surface. This process is called secondary recovery. Sometimes secondary recovery of an oil field yields several times as much oil as primary production of the same field. Even newer and better recovery methods are being tested today. Transporting crude oil from producing fields to refineries is another important job of the oil industry. Pipelines are the major arteries in the transportation of oil. In the United States, 211,000 miles of pipeline carry crude oil to refineries and oil products to terminals. Pumping stations along the way keep the oil flowing at a rate of 2 to 3 miles per hour. Oil is also carried by railroad tank cars. barges, trucks, and between nations by ocean-going tankers. The largest of these ships can carry more than 2 million barrels of crude oil. Eventually, crude oil arrives at an oil refinery. Here it's changed into fuels, lubricants, and other useful products. One major step in refining is called fractionation. This process separates the hydrocarbon molecules that make up oil into different parts, or fractions. The oil is first heated until it vaporizes. Then the vapor is passed into the fractionating tower. As the vapor rises, different fractions condense at different levels and are drawn off. At the top of the tower, fuel gas is drawn off. Gasoline condenses at the next level. Then kerosene, heating oil, and lubricating oils. Heavy fuels are removed at the bottom of the tower. As all these fractions are drawn off, they are further refined and processed. Modern refining techniques have given us high-quality gasoline and lubricating oils, jet fuel, fuel oil to heat homes and buildings, diesel fuels to power trains, and over-the-road trucks, and asphalt to pave our streets and highways. In addition, scientific research is constantly finding new uses for the many petrochemicals that come from petroleum. Among the many important products manufactured from petrochemicals are plastic containers, paints, fertilizers, insecticides, synthetic fibers, and animal feed supplements. The industrialized world is greatly dependent on petroleum and petroleum products. Without oil, modern transportation would soon halt. Industrial production would stop. And mechanized agriculture would cease. Because it is so essential, oil will continue to play a major role in the economies of the industrialized nations.